Hello people, welcome back to the channel. My name is Darsh Joshi and I'm a BTech Computer Science Engineering and I'm currently working as a developer in a tech company. I rushed the intro because why not? Let's move on to the content basically. And that's the point of running the intro fast. So yeah, today's topic is polymorphism and this is the second video on polymorphism. We'll be learning about operator overloading in Python and we'll also be learning about custom vector classes. Let's start. What is operator overloading? Using operators with custom objects like plus for addition or multiplication symbol for multiplication instead of calling the methods like add or subtract. This was abstraction content, by the way, which I just erased. I recorded this video before, but audio was not being recorded for some reason. Yeah, you can use simply plus or multiplication instead of add or mult. Yeah, that's the point of operator overloading, and we'll be studying that. Why should we use it, you may ask? We use it because it gives you a cleaner syntax, it gives you more readable code, and it feels more natural to see it or read the code, and you simply understand what it does instead of complexifying it using the method calling. Yeah, that's the purpose of it. Let's move on to the next thing, which is special methods. Python uses special methods, which is underscore add underscore parentheses. We can replace it by a symbol plus. Same for multiplication. And when I'm saying str, it means it would print out the result of whatever is mentioned in the str method. And these are called dunder methods, or yeah, that's the name for it, and that's basically how we overload our operators. Move to the next part, which is a vector class. So what we understand from a vector would have two things, which is a direction and a magnitude. So if we take an example from physics or mathematics, vector is basically a good example of vector is velocity. Velocity would have a direction as well as the speed in that direction, or a specific magnitude in that direction, while on the other hand speed is a counterpart of velocity. It doesn't have a direction, it would just be a magnitude value. So yeah, that's what we'll be looking at in this part of the video. So let's basically make it this code. What I'll do is class vector, and inside vector we'll have some methods, which the first thing is init, and init would have self x and y. X and y is basically the directions, and it would also contain a specific magnitude for those directions. Inside this we'll do self.x equals x, same for y. Yeah, that's it. What we'll do, we'll define another thing. Let's call it add self and other. So other for vector addition, if you don't know, basically add the x value of it and we add the y value of it. And this also will be doing the same. So when we are adding, it would return out a vector, an instance of the vector class, as we can call it. It would have self.x plus the.x comma self.y other.y. Now let's try this method out. What we'll do, v1 is a vector has value 3 and 4, let's say. I'll make another vector, let's call it v2, and it would have the values 1 and 2, let's say. So calling. Yeah, now let's do it. Let's also use another method. Let's call it str1, or basically return whatever we have. We'll use a string here. Will self.x, self.y. I think we should put them in parentheses because vectors. And let's do it. Basically print v1 plus v2. Let's run this, and we are getting 4,6, which should be the obvious answer. Now let's try with multiplication as well. Simply just copy this, add them. Instead of adding these, simply putting this here. Good to go. I copy this, the thing for multiplication. For some reason this run button isn't working for me. Please. Okay, I forgot to change. Now it should work perfectly fine. I'll clear the screen first. Yeah, good to go. So yeah, that's how we work with the vectors. Overloading addition, we just did that. Overloading multiplication, we did that. Overloading magnitude is what we'll be doing now. So magnitude is basically finding out the numeric value. Like speed and velocity are different things, but speed has a magnitude and velocity also has a magnitude, but it's divided upon directions. We'll define a magnitude here. As self, what we'll do, we'll return the magnitude formula. Is self.x squared and self.y squared, and this entire thing to the exponent of 0.5, which is square rooted. Let's try magnitude of v1. Magnitude. See, magnitude of it would be 5. Square would be 9. 9 plus 4 square 16, which would be 25. Square rooted, get the output of 5. Yeah, that's operator overloading. And here's a little code challenge for you guys. You have to create a vector with this specification, perform these tasks on them, and comment down the code in the comments. I'll be checking that out when I get to them, because most people don't put their codes in the comments for some reason, not sure. Yeah, that's operator overloading, and this would be the expected expression for the output. And let's conclude the video so that I can record the next one. So operator overloading basically gives you custom behaviors for operators, cleaner and expressive code. And vector classes basically show real world usage. I think I forgot to tell you the real life use cases of vectors. Vectors are basically used in physics simulations, like if you're making a game, it would have a specific physics like force, acceleration, velocity. Used in computer graphics like drawing shapes, transforming those shapes, scalings and rotations. It's used in lighting calculation as well in computer graphics. It also plays a major role in machine learning. Vectors basically represent data points, features, embeddings. And another use case for this is robotics. So the movement of robotic arms, path planning and orientation basically help the robots to understand how to move in 3D space accurately. Vectors can also be 3D, by the way. We have used 2D vectors here because it makes the job easier for me and for you to understand. Yeah, that's it for the video. Please subscribe to the channel, like the video if you liked it, or tell me what you didn't like in the comments. Yeah, see you in the next one.